Welcome back to Python! Today we're going to be talking about web scraping. If you're not familiar with web scraping, this is basically the process where we can pull any data that we want from a website as long as it's legal. Let's get started with a quick explanation of what web scraping is. So when you scrape data from a website, basically what you're doing is writing a bot or a script to then interact with the website and gather data from that website's database and then pull that database content or that information from the database back into your own server or your own database. And so many people will do this just as a quick way to collect a lot of information at one time. Other people, though, use web scraping as a tool or a weapon to try to collect as much information on their competition as possible and to try to potentially overtake a customer base from their competition. Now for us, web scraping is not going to be that intense. We're going to think of it more like a tool. And luckily for us, web scraping has been around for a long time. So in Python, we have a lot of options on how we can scrape information from the websites as long as we're doing it ethically. Now the two main libraries we're going to focus on today are Beautiful Soup and the request library. And honestly, the easiest way to learn web scraping is to do it. So what we're going to do today is start with an example of how to scrape data from GitHub. So let's say we wanted to view the top 10 repositories on GitHub right now. If we wanted to do that manually, we would go to github.com/trending, and then we could scroll up and down and click through the #1 trending repositories. But this takes time. It also takes energy and effort. What if every day when you wanted to get on your computer, you wanted to have a list of the top 10 repositories from the previous 24 hours already loaded for you? So when you sign in, those repositories are available to you. Well, how we can do that is create one of these scripts. We can create one of these scripts to gather that information from GitHub's website, save it to our database, and then we can access it on our machine. So that's what we're going to be practicing today. So to start, we need to install our libraries. To do this, we're just going to go !pip install Beautiful Soup 4, and then we're also going to make sure that the request library is installed. Now, as always, when we're working with the library, the first thing that we have to do is make some imports. So we're going to import from BS4, which is Beautiful Soup 4. We're going to ask to import Beautiful Soup, and then we're also going to import the request libraries that we downloaded. That takes no time at all. The next thing we have to do is make the connection from our machine to the machine where our website is hosted, or to that database. So the first thing that we do once we have our imports taken care of is import the URL. So we are just going to use github.com/trending, and we're going to set that as the URL. After we set the URL, we're going to ask to create a response. And this response object is going to be equal to the request library and then the get function within the request library. And then we're going to ask to get that URL. So this is basically just sending that first request out and activating that connection between our machine and GitHub. Now, once we've got our response taken care of, what we're going to do is say response.content, and this .content is a function built into Beautiful Soup that basically strips all the HTML from the website and creates text out of it. So we're going to say response.content, and we're going to make that equal to our HTML content. Now, after we have the data for the page that we want to scrape, we need to parse that data and find the elements that we're interested in. And this shouldn't really sound new to you. If you are familiar with computing, then you know that HTML uses elements and tags like the div or the body or span or class, and those are the elements, quote unquote elements, that we are interested in on this page that we want to collect. And so we have to specify those elements and then pick those pieces out of our puzzle here, or out of our soup here. That's why it's called Beautiful Soup. It's a soup of a bunch of elements, and you want to narrow it down just to the elements that you're interested in. So what we need to do before we start is figure out which tags we're interested in. So what we're going to do is go over to GitHub's website, and then we're going to hit F12 on our keyboard. And then once we have the inspection view open, we could start to sort through the HTML and try to find the elements we're interested in. But you never know how long this HTML is going to be. It can be a lot of information to dig through. And so that's kind of a daunting task. A quicker way to try to figure out what element you may be looking for is to highlight the element that you're interested in, right click on it and hit inspect, and then you can be automatically taken to that element in the HTML code as long as you are inspecting it. So you'll see, for example, here I clicked on the title of this repository, which is called get cursor/cursor, and you see it takes me to a span that is called data-view-components. And that data-view-component is inside of another header that's called h1 or heading 1, and heading 1 here has a class that is equal to h3 space lh-condensed. So if we pull just this h3-lh-condensed and then collect the information from within that tag, we can find the name for this repository right here. So that is the tag that we're going to be looking for. We're going to be looking for this h1 tag that we just saw with the class attribute that is set to h3-lh-condensed. And so to get started doing that, the first thing we're going to do is make our soup. So we're going to take the HTML content object we created up above, and we are going to pass that through the beautiful soup function. And we are specifically going to use the HTML.parser, which parses HTML code, and we're going to make our soup. So we're going to set that equal to a new object called soup. Now, after we've made our soup, we want to define which tags we are looking for in the soup. So we're going to say soup, which this is actually just the name of whatever object that you're interested in, but ours is soup.findAll, so find all of these possible tags, and then we specify that we're looking for the h1 heading or the h1 element. And then inside of the h1 element, we're looking for anywhere where the class says h3 space lh condensed. And we're going to call that the repo tags, or the tags that we've collected. And so how we're going to do that is create a new object. In this case, we'll just call it repos. You could call it tags. You could call it whatever you want. And that'll just be an empty list. And then with the repo list, what we're going to do is say for repo in repo tags. So for everywhere that there's a tag in the repo tags object, I want you to go through the repos and then append the repos text that you can strip. So we're basically taking the repo object and then stripping the text off of it and then appending it to that new list that we just created called repo, and then we're printing it. So let's go ahead and run that. And there we go. Just like that, we've scraped some data off the web. And let's see how closely it matches the actual GitHub website. So if we look over here at our GitHub trending page, we'll see that the first repository is called Get Cursor, and it is by Cursor. You'll see that we've got a little bit of extra text in here. So it looks like it's giving us that / and then a new line notation. So that would be something that we might want to clean out. We'd also probably want to get rid of all this extra space between cursor. And you'll see that that trend repeats across the entire list. But what's important here is that it pulled the correct information. So let's make sure that that lines up. So we got Get Cursor and Cursor, Hail and hail.github.io, ChatGPT Next by Yidya, Binary Husky by ChatGPT Academic, Vinkanger by Coverletter GPT, and so on. So you'll see that we did successfully scrape all this data off the website. And honestly, that's it. That's all it takes to scrape data off of a website. It's really not that hard. The hardest part is finding the information that you're interested in, is finding that element that you need to scrape, and then making sure that your script actually, your Python actually accesses that element correctly so you get access to that data and you can pull from that data. Sometimes you'll access the correct element, but these websites are updated so frequently that the class or something has changed since the last update, and so you have to go research through all that data. But no matter what, searching through the HTML to find this class or this element that you need is going to be quicker than going page by page by page and downloading or writing all of the information on that page by hand. So web scraping can be an awesome tool to collect data off the internet, as long as you're using it responsibly. So you may be saying to yourself, when would I ever use this? How is this going to be helpful to me in my everyday life? And the fact of the matter is, as with everything else we've talked about this semester, there's always a place for this tool in your life. So let's say you're a market analyst or a business analyst for a company, and you need to monitor the prices of your competitors, or maybe you need to monitor the stock of your competitors off their website. And so we could do this manually by searching for their products, recording the prices, and then spending the time sharing that information back and forth. Or we could web scrape and automate this process and create a database and then pass that information across the entire company so that people can automatically run this script, see how things have changed, and update their market to match the current retail environment or the current competitive environment, so that they're never losing or trying not to lose as little as possible. So in this case, we're going to practice this. We're going to practice a real world example. And in this case, we'll be using Best Buy. So in this example, we're going to pretend that we are a competitor to Best Buy. Let's say we're Costco. We're Costco, and we want to know what price is Best Buy selling their iPads at, so that we can try to undercut Best Buy's iPad prices and make a quick extra buck as we go through a holiday weekend or through a holiday season. So we want to keep close tabs on the price of their iPads. And so to do this, we're going to go through the exact same process that we went through in the first example. The first thing we're going to do is make our import. So we're going to come down into our code and we're going to say import the request library, and then we're going to import BS4, Beautiful Soup 4, and we're going to ask for the Beautiful Soup function. Then we've got to make a connection to the website. So we are going to specifically use their search page. Their search page looks like this. It's got a lot of elements on it. But the nice thing about the search page is we theoretically could automate the process and go through every single page of their iPad data. And so we're just going to pull the address for their search page here when we've specifically looked up the keyword iPad. And so we've got this URL right here. And then what we're going to do is pass the header information. The header information is just who's actually accessing the data. Sometimes websites want this information as like a security check to make sure you're not a bot. Other times it's completely unnecessary. As you saw in the first example, we did not pass header information. So it just depends on the website. With Best Buy, when I did not pass the header information, it actually always forced me to have an empty list returned. So it would never provide me an output. It would never print me out a list. So we set the header. The header is just the information about who you are. So we say user agent, and then I was working with Mozilla or Firefox initially. And then after that, we set our response. So we're going to say, hey, request libraries, please get this URL that I specified up above, and please use this header. So say that I am a user agent using Firefox, and then we want to save that as a response object. After we've got our response object set up there, we have collected all the data for our website. Next, we need to parse that data. So what we're going to do, again, is use the Beautiful Soup function, and we're going to pass the response.text. So we're going to take our response data, turn it into text, and then we're going to use the HTML parser, and we're going to save all of that as our soup. Now, from our soup, we want to find a specific item in our soup. So this is where we need to figure out what elements do we want. And in this case, because we're pretending that we're interested in models of iPads and prices of iPads so that we can create or have a competitive price as Costco versus Best Buy, we want to collect the name of the item and then also the price of the item. So what we want to do here is highlight the two elements that we're interested in and figure out what their element tag is. So we'll start here with the name of our object. So I'm going to highlight the Apple iPad here. I'm going to right click, inspect that element. And it might take a second because they have a lot of JavaScript on this page, but you'll see that the name of our item comes up in a couple of different places. And so this is when it gets important that you're actually paying attention to what level you're collecting your data at. And so what I mean by this is, for example, what it highlighted here for me is just an attribute tag. Well, I don't just want this attribute tag. I want to find a universal tag or a universal element that I can iterate over the whole page with. So then we go a level up and I see that I have H4 class is equal to SKU title. Okay, well that'll be useful further into my soup, but to start off my soup, that's not going to help me very much. So we need to go even further up. And then you see we get into some badges and some columns and some columns. Eventually we get to an item or div that's called list item. And then finally up above that is when we finally get to the div that opens this whole body section or this body section of the search page. And under that div, we have a div that has a class that says shop-sku-list-item. And that div is open for all of the items on this page. So that is actually going to be the div that we want to try to call on and find every example of so that we can gather that information off of the website. So that is the element that we're interested in right now, is that single div item. So we're going to say that our soup dot find all the instances where this div exists, and the specific class that we're looking for is the shop SKU list item, and we're going to call that our product tags. And now we actually need to extract that data. So we're going to start by creating a new object that's called products, which is just an empty list, and then we're going to say for the products in the product tags. So for each product in our total product soup, I want you to go and find the name of that product, and you're going to find the name of that product by taking the product.find. The find function is again similar to find all, except it's only finding one instance. And we are going to call on the find, or we want to find that element that specifically mentioned our name. And so if we scroll over here on the right with Best Buy, that specific name that we're looking for is that H4 heading, and the class is equal to SKU title. So that's what we put right here, the H4 heading, and then we're looking for the class where the class is equal to SKU title. And then with that SKU title, what we want you to do once you found that information is collect the text and then strip the text out of that heading. Now we're going to do the same thing for the price tag, except the price tag will have a different element that we have to parse. So what we need to do is go over to Best Buy's website. We'll close out this inspection grid, come over here, find the price that we want to actually access or be able to collect the text from. Then we're going to right click, inspect it. It might take a second to load again, but then we finally find the price. And you can see here, now we have another element to keep track of, or another thing that we have to keep track of. So you'll notice that the price of this iPad is actually inside of a div, and that div has a class name on it, which is price view hero price, and then also price view customer price. And that's because this item is on sale right now. So it's got two classes attached to it. You do not have to put in both classes, and you do not have to use an or an and or anything. You want the regular price of the item, so you would just write price view customer price as it's shown right here. And so we'd say in here that for the price tag, we want to do product.find the div where the class is equal to price view customer price. And then we're going to come in here and add a conditional statement, because there is the chance where there's something listed on the website that's just like a search result or a troubleshooting article that does not have a price available to it. So we need to be able to put NA if there's not a price available. And in the other cases, we need to be able to actually grab the pricing information. So as you saw on Best Buy's website here, the pricing information, the actual value that we see on the website is in a span element, and that span element has a class that is equal to SR only, and then that SR only is what will give us our actual price for each of these items. And then after we've collected those elements, again, we're going to collect the text from them, and then we're going to strip it away, and then we're going to append all that to the products list, and then we're going to print the products out. So let's go ahead and run this and see if we get any results. This one's going to take a little bit longer to run just because there's more data there, and then on top of that, it's also more complex. So like I said, there's a lot of JavaScript on that website, and it might just take some time to get through all the nonsense, to get through the soup. Okay, perfect. So it came back. It took about 31 seconds. Actually, not too bad. And let's just read through our data here and see if we got what we wanted. So we can see it's pulling iPads. It's telling us that your price for this item is whatever the price is. Looks pretty good, no NAs. It's also collecting other data for us, like the size of the screen, as you can see here. It also tells us that some of them are the latest models, some of them have Wi-Fi, some of them have cellular connection. It tells us the size of them because they put that in their heading. So this actually has more data probably than what we wanted. So we could actually take even this products list and parse it down and clean it up even further. So for instance, like all of this information that says Apple, we could delete, and we could just keep 11-inch iPad Pro because Apple's the only one that makes iPads. That's their product. This Wi-Fi, maybe we want that in a connectivity list, and then maybe we want the size of the iPad or the total memory of the iPad to be in a different category, the color in a different category. The price, we could cut all of this information off and just keep the numbers. So bottom line is, this is just the start. This is just the first step in the pipeline to scrape all this information, collect it, and then use it to your advantage for, your competition, for your business, whatever it may be. Now, the thing with web scraping is you have to be ethical about it. So I put a little section down here at the bottom about how to be ethical with web scraping. Some people feel that while the internet is a public place, it's obviously public domain, or you do have public domains that you can access, there's information there that is personal as well as private and protected by intellectual property. So web scraping is not permitted on every single website. You have to be ethical and responsible about it. For instance, Google.com does not technically allow for web scraping. If they catch you web scraping, your account can be banned forever. Same thing with Google Scholar. Google Scholar is a gigantic database of academic research, and web scraping is against the terms of service. You can be banned for life by web scraping Google Scholar. So you just have to be careful on who you're working with. If you have the potential to talk to the person that you are working with, if it's like for a research project, then you can obtain their permission to scrape the web. You also have to remember that if you're collecting information off a website and it's not your data, you need to attribute the source of the data and, give some credit to the people who collected the data. So you just have to be careful with web scraping. It is a very powerful tool. As you saw, if we were a competitor to Best Buy right now, we'd, be having to sell on iPads. We'd be keeping up with our competition. But it doesn't always work like that. So you've got to be careful that you follow the terms of service of the places that you want to web scrape. And that is it. Honestly, web scraping is not that challenging. It's 4 to 5 steps in your pipeline to collect the data. If you want to parse it any further than that, then that's on your own time. The hardest part about web scraping is finding those elements in that beautiful soup of HTML. That's why it's called beautiful soup. And just make sure you use your tools when you can. So make sure that rather than combing through the elements one by one, you use that inspect tool as much to the best of your ability so that you can move these things along and be as efficient as possible. With that, that's all I had for you guys today. I hope you have a great day, an even better rest of your week, and I'll see you next time.